Hello. I am about to solder together the second version of a module which I designed, although it's just mostly cobbled together from other schematics, which were then cobbled together from other schematics. It's just a very basic amplifier. But first, I was going to show off a pastry brush duster, if I can find it. My desk is a mess. I have to clean it up. So this is my last soldering for a little bit. Lost the pastry brush duster. Hello. Pastry brush duster. Oh, here it is. All right. Hello. This is the special EMS brand IKEA pastry brush. It's very soft, so I thought it might be good for dusting modules. Yes, does a good job. However, the bristles, the clearance is barely, actually it's fine for this. Oh, look at that. It's doing a great job just dusting everything off. But on anything with slightly taller knobs, it's not great. It gets in the way. This is what I had before. It's just the cheapest nylon brush from the hardware store. It does a fine job. But yeah, the barber shop neck cleaners are probably softer. And, you know, you want to treat your synth right. A nice soft, gentle brushing. Okay, so this is the module that I'm building. This is the Enthusiastic Electrons Booster, spelled with a TR because it's a TR, a tip and ring stereo jack input, line level or slightly below line level, and it splits it out to left and right mono outputs with gain control. So that's basically if you want to have anything like a Korg Volca of some sort, or anything that's external with headphone, stereo headphone out, because I had my Korg Volcas and I wanted to bring them into the synth, but the problem is they're, you know, TRS jacks, and I wanted both left and right because sometimes you want stereo. So anyway, that's what this is. This just does it in one simple module. And basically, I did it partly because I needed that, and also as learning PCB design. So this is one of my first modules that I've just designed, and this is way too many parts for. This is my first pass at it, and it's just way. Oh wait, no, sorry. That was another one that was way too complicated. This is the one that was way too complicated, the butter that I put together the other day. This is the first version of it. Sorry, I'm getting confused here. This one was like way too complicated, didn't work, so I redesigned it much simpler in a way that actually does work. This one worked, actually. This one was fine out of the gate, the first one. However, I made a couple of revisions, and the revisions are as follows. This adjusts the gain, and it starts out at 1-to-1. So it starts out at unity gain because it's a non-inverting op-amp configuration. So it starts out at unity gain because I figure you know, for this I don't care about making it totally quiet, and also anything that it's coming from also will have its own volume control if I did want to make it quieter. But it starts out at 1-to-1, which is line level headphones, which is also too quiet for Euro rack. So then it goes up to more. And what I wanted was, when I designed it and I did all the testing, I thought a 20K linear potentiometer adjusting the gain with the op-amp would have been ideal. So then with that, it would have been, if it's a standard 2 volts peak-to-peak line level input, then right about noon. Halfway would be, that would be ideal. Somewhere around here, somewhere in here, you know, adjust to taste would be ideal. And then you could go more if you want more. If you want to, it would either distort a line level signal, or else if you had something that was quieter, something that's not the full one-to-one, then you could also, you have more leeway to boost other things as well. So, because it is the booster, so you want to be able to, you know, you want it to go to 11. So, anyway, the problem was, after I did that, I discovered that you can't actually get a 20K, a dual 20K potentiometer, B20K potentiometer. So, because this is the dual gang, because it's stereo, you can only get the 10K. And I had already had a bunch of 10Ks, and I was going to reorder. But anyway, I looked everywhere. I couldn't find them. Maybe they exist, but I haven't been able to find them anywhere. So, in the interest of using parts that you can actually get, my redesign, basically all it does is it adds another resistor in series with this, so that it doesn't start at unity gain. Now it starts at somewhere in between, which is also fine. You know, because even if you started here, this is actually probably the quietest you'd ever have it. So anyway, you could put in whatever resistor you want. You could have no resistor if you just wanted to be like this with the new design. You could put in a 10K, in which case all the way here would be about what you want, and then it would just get really way too loud from there if you want to do a lot of gain. But I figured split the difference. So I'm going to start out with a 6.8K potentiometer, somewhere anywhere between 0 and 10. You could do a 5 point, whatever you want. But I figured 6.8K, lean, a little heavy. So anyway, so that's one of the revisions I made. A couple other things I did were I accidentally left out some of the labels on the somewhere. Some of the things in here were a little confusing, so I just cleaned up the silk screens, the labels of the values of various components, removed some words that you don't actually need. And then I also, I was like, while I'm at it, I might as well redo, because this JLC PCB printed their order number right on the front of my panel, and I like this panel, but also the letters, the text is just way too tiny. They're stereo line in. It's very hard to see out. So anyway, here we have the revised version 1.1, and here's the new panel, which has bigger text. I made booster all the same. Stereo line in, much bigger, easier to read. I got rid of the values here because they're kind of arbitrary anyway. It's just, you know, until it sounds loud enough. And put a line in instead. So anyway, and also it's blue, because for some reason, the first time I ordered it, white was just as cheap as any other color. But this time it said, nope, white's a special order. It'll be a lot more expensive, but blue was not. So anyway, and it looks sharp. And with these, the way that this is designed, this is just a PCB. You can see the raised, this is slightly textured pattern back here. That's actually a copper layer, where normally you'd have traces or something like that. So it's copper layer covered with the solder mask, and then here's the copper layer, which is silver, with the solder mask removed right around the line in thingy. And then the rest is just silks. So anyway, right now I'm going to build 2 of these. Oh, also, I also made, this is the first version, which, you know, it works fine, but this is also it's the same board underneath, but I also made another panel just to see. So this is the 1U version. I didn't make another 1U one because even though the order number is printed there, it's fine. So anyway, I'm going to build 2 of these at once. Sometimes it's easier to do 2 boards at once. Sometimes it's not. But I want 2 of them. And there we go. You can press, there's a button when you place your order with JLC PCB that says do not print the order number. And it's like less than $1 to have that option. So it's not a lot, so I figured why not? For the panel, and then, but you can also specify where, and I can see now this is right in the middle. This is the order number on this, so in the future I will specify where it goes, now that I know you can do that. Anyway, this is all a learning thing. Okay, so I've got 2 tops and 2 bottoms. So here's my here's a schematic. If I can find. Boom! There it is. There's the schematic. I can put a link somewhere. But as you can see, it goes in, basically it's 2 identical circuits for the left and the right. And it's split between 2 boards, the top and the bottom. It goes in, from the top left, you'll see it goes in, there's a 1K potentiometer going to ground. That's sort of, what is that called? Pull down resistor, so it doesn't float around. And then also, and then there's the capacitor, the 10 UF capacitor, and another 100K resistor to ground, and that sort of acts as a low pass filter. So that'll smooth out the incoming bit, but it also remove any DC. The original schematic that I was using was the AI synthesis one, which is identical to I think the Todd Barton stomp box adapter. And for that, it was using a 1M pull down, which reduces a lot of the low end. And that's fine if you want to bring a stomp box in, if you're doing something like a guitar, and you want to get rid of a lot of the noise. But here, the things I'm bringing in are not going to be as noisy as a guitar. And also, I don't want to lose all the bass. I want to keep some of the bass, so made it a smaller value. And then it goes into the op amp. It's just a TL072, which is a standard op amp, and it's going into the positive, so it's a non-inverting, which means the same direction goes in as out. The same, if it's more than coming in, then it's more going out, as opposed to inverting it. And then there are some capacitors and resistors to smooth things out, and and then the 10K potentiometer to adjust the gain, because then they're coming out of the output, going back into the inverted input. That's how a op amp amplifying works. And then it goes out, and there's a lot going on then with the well, it's not a lot, but there's an LED, a transistor, a diode, and a resistor, 2 resistors, basically on the outgoing side there, which is just to drive the LEDs, and that's designed to drive the LEDs in a way that won't mess with the output level. That's it. So back to soldering. This is a very slow start to this stream. Okay. What am I going to start with? I'm going to start with resistors. So what do I have here? I've got on this. Start with this board. I just usually place everything first. So I've got 6 100K resistors. Just recently, as in yesterday, reorganized I had components all over the place, and I can generally find things, but now it's better. I keep all my components in the original bags they came in, just so I'm sure what values they are, but then I have everything, all the resistors in one place, all the capacitors in one place, with some divisions as well, like radial capacitors versus non-polarized. 1, 2, 3, 4, 5, 6. And I'm doing 2 of them. 1, 2, 3, 4, 5, 6. And I always leave the bag lying there so I can double check, like, oh wait, is this 100K? Yes, until I'm done. So where are all these? Here they are. This is the silent part. I'm not so sure how good I am at talking and soldering at the same time. If anyone wants to stream music, that would be great too. Just let me know in the chat and I will stop streaming this and make way for music, because music is great. I have in the past set up sort of generative patches that were going on, so I could listen to a generative patch and solder at the same time. And what happens is I get really involved in the generative patch because, you know, there are knobs to turn, and then I don't get much soldering done. And I make very basic mistakes. With the soldering, not with the generative patching. Not because I'm great at patching generative patches, it's just that the nature of it makes mistakes part of the process, so there are no mistakes. Only patches. I soldered, so I have a whole bunch of modules that I placed in order all at once with JLC PCB with these modules, because the most expensive part is the shipping. So if you do several at the same time, then that saves money. So I did just get a batch of several modules, and I put together the other one that I was talking about, the one that was way too complicated. That was it's just a trigger through, but you could route two triggers to either of two outputs, and in addition, each of the outputs had a button for a manual gate. So that was basically for like I designed it for an XY sequencer, so you could manually advance an XY sequencer that doesn't actually have any manual controls over it, i.e. the nonlinear circuits bin dubba, which for some reason when I saw it I was like I must build that module, and I had never done surface mount before, and that module was the one where I said I'm going to learn how to do. I'm no longer afraid of surface mount. I will do it because it looked really friendly, you know, and it actually is really. I now prefer it to through-hole. The nonlinear circuit boards are all they're great because they use the same basic, easy-to-get components. I've now moved on to the 1K. How many are there? There are 6 of those as well, times 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, the nonlinear circuits, they're interesting modules, creative. The boards are just really friendly in their layout. Just there's plenty of space. They use the largest surface mount components, which are 0805. So I just do that with the iron, and it's fine. You know, and tweezers and a magnifying glass. But it's quite peaceful, and I heard people say that before, and I never quite understood until I actually started soldering the surface mount. But there is also a lot of components on that bin dubba, so I thought, oh, it'll be easy. But then there were many parts, so it took a while. But and I don't use it all that much, in part because there's no manual advance. So now that I have that module, maybe I will use it more. But I'm grateful to that module for getting me to start doing surface mount. Now this particular module, it's actually the second one I designed. The first one is a mixer, which is pretty messy because it was my first design, and I tried to make it small. And that one I did through hole just because I figured I'd start out that way with something bigger and easier to troubleshoot and make changes if there were mistakes. This one I chose to do through hole instead of surface mount because this module, I figured this is one that I thought I would like to share with people. I figured there could be a demand because a lot of people who are just starting, like I'm just looking at my own path in synthesizers, and I think that other people, I've heard other people sort of taking a similar route. I started out with something. I had a bunch of Korg Volcas, and other similar types of synthesizers, and then got into Eurorack, and also I've done electronics, but not and like building my own stuff. But then this was perfect because it's DIY, but it's also then it makes music. So anyway, this module I thought would be handy because I haven't seen anything that does this exactly, and I feel like a lot of people want this exactly, and it's very straightforward. It's just like the most basic amplifier. If you're looking up, how to do an amplifier circuit, this is it. But it's split out, doing specifically the TRS stereo to dual mono. So I wanted it to be as something that's easy for other people to assemble, and more beginners will be doing through hole than surface mount. Hold on a second, I gotta. Hello, I'm back. Sorry, my my daughter was asking for something, and so I got that for her. Some clay. All right. So anyway, as I was saying, yes. So as I was saying, I think I would. I'm interested in. I'm not looking to get into mass production of modules, but I certainly would love to share ones that work. So yeah, this is definitely one that I will share. And if this works out, if this one works out, and once I have all the bugs worked out, I will make a larger batch of boards. I could also I'm definitely big into the idea of open source. So if anyone wants to design, just print their own, I'll share the files at some point once I get the GitHub working again. But also, I will, I don't know if I would do kits, but certainly boards and panels. Great, and yeah, and this one worked out. This, oh wait, this is the showing off. This is one that I would definitely share as well. It wasn't working when I first built it, but something was wrong with one of the LEDs I used. So this is the bin dubba. So the way this works is you have your X and Y inputs, and you can route the X and Y input to one of these two outputs, and then so either one can turn on or off, or so you could have the A input going to both both outputs, or split it like that, or swap them, turn one of them off, and then also these are buttons which are manual gates. So, and there's a little LED is underneath it, so the whole thing lights up through. It's kind of cool. Not as, it's a little blobbier than I would like. I think a higher resistor value, making the LED a little dimmer, probably would have been a good idea, but it also doesn't matter. All right, so okay, I think I have. Wait, do I have all the resistors? No, there's one more. The 6.8K resistors now. I did not have any of those, so I had to order that value. Again, for some reason I feel like 5.8 is probably a little more common, but like I said, I wanted to lean a little louder than softer, since most of the time I would just crank it as much as possible without distorting. So this is 6.8. Oh, wait, no, I need 2 per board, 1 for each, 1 for left and 1 for right. Yeah, and also in terms of these panels, certainly send some, send some around to EMSers who are interested as a first, still beta testing. Okay, here, so these 6.8Ks are going in series with these are to taste. As you can see, I'm placing all of these. That's the one thing I do like about through-hole over SMD, and that's the only thing in terms of like the, it being a peaceful activity, is you can place all these resistors ahead of time. If it gets too crowded, it's not fun afterwards and it's not worth it. But you can just sit around in a comfortable chair drinking some coffee, placing resistors. But then after that, it's all solder fumes and extractor fans. Speaking of which, this is my last. I guess I could still do some diodes. I don't want to do... why not? They're spaced out enough that they won't all get in the way. So I'm going to heat up my iron. The good old Hakko FX888D digital iron. Heats up very fast. In fact, it's already ready. Just turned it on. All right, now diodes. I've got the 1N5817s. All of these parts, except for maybe the stereo jack, are easily, you can get them all from Tata, and they will arrive instantly for a low price. So this is the 1N5817 diode. I need 4 of those, 2 per side. This is a Schottky diode. So it is whatever makes Schottkys good versus a Zener or a sort of more standard switching diode. They are good for protection. They're really good with stopping reverse voltages. So these go near the here they are, near the input, the power supply. And so there's one going for the positive, and I have to make sure they're oriented the correct way. So the line to the line. So this is to make sure that the 12 volt positive is going in, and then in the opposite direction that the negative 12 volt going back up to ground. Let's put that in backwards again. Put that in, so that's that is basically, if you plug it in backward, no power will go to the module and nothing will blow up. Now, playing with op amps a few years ago, when I first really was starting to play with op amps, I was just breadboarding some, and somehow I managed to make a potentiometer burst into flame with just 12 volts either way, which I thought was really cool because I didn't know you could even do that with 24 volts. And also it was just breadboarding it. That was some magic smoke. Anyway, this is also, I'm also using, in addition to that, I'm going to use a shrouded header. So that's two ways to make sure that this module is not going to blow up. And then I have one more diode pair on each one, which is, this is a standard, oops, this one I've got many of these. This is, if you're going to have a bag of diodes around, this is the one to have. It's the 1N4148, and it's just a basic diode that makes voltage, current flow in one direction only. This is what I use in an OR circuit to make sure that, like that butter one, or if you're doing an OR, like a proper OR circuit where you have, it's like a mult. I was showing this the other day. This is the first module I ever built. I just drilled some holes in a blank and then wire them all. It's just a passive mult. The second one I built, same thing, except instead of just wiring these together with leads, and these are just offcuts from resistors. Instead of just wiring them together like that, there are diodes in each one, so that if you have a voltage going in here, the current going in here will not come out these other ones. So you can have multiple inputs, and it will, with one output, and it will all just flow in one direction. So that's your basic OR circuit, and these are good for that. And that's what's in butter as well. This one. So your voltage will come from either the button or the trigger input, which is why it's called butter, because it's the button or circuit. Even though I think butter would be a better name for a really smooth filter. That'd be an appropriate name for a smooth, buttery filter. So I don't even know what that means, but I also do know what it means. You just know. Okay, and these are, the orientation is important, so the line on the diode lines up with the line on the silk screen print. Okay, there. That's a lot of things. Solder, iron, silver thingy, helping hands. We'll start here. Okay, do one end there, and then I reflowed and pulled. This is just my latest current way that I do this. Then I reflowed and I pulled the leads up so that they're perpendicular to the board, and then the other ends, now it's in place so it's not going to go anywhere, so the other ones I pull up perpendicular before soldering. I'm going to reflow this a little bit more. Alright, so those were the power diodes. This technique hurts because these get very hot, but not too bad. I could use something like this to hold them, and I would if they got really hot, but they seem to be okay right now. Oh yeah, I was trying. I was doing this with a Buffaco. I don't remember what module it was, but some very dense board, and I was pulling these up, and they were all over the place. And I was using this to pull them up, and I actually broke some resistors in half because I was pulling too hard. But it was also, I had to pull so hard that my hands were on for a while, and so it was burning, so I had to use the little grabber tool instead of my hands. Ouch. I might stop doing that soon. How are they? Everything's looking... Nah, it's not beautiful, but it's fine. It's reasonably flat. It's not going to cause any problems. Anyway. Love that stuff. This is a Weller little pot of whatever this stuff is. Hang on, I'm flipping. This, whatever this material is, and the bottom of this, all the little fine little bits of solder were falling out the bottom, and it kept falling off. So I had to tape it and tape it and tape it. So, not. I wouldn't recommend that one. I suppose I could also, yeah, I could push up from the other side on this resistor if the idea is to make it flat. Ow, that was worse. That works for capacitors, not for resistors. Good. Another one of the same board. These are the Schottky barrier diodes, rectifiers, what have you. Okay, my fingers are starting to feel the burn. I'm doing that by hand, so Now, let me check the chat here. Oh yeah, you can push it straight with the Chance Enthusiast is saying, let's see, I'll try that out. Push it, well, yeah, start it out by hand. Oh yeah, nice. Push that straight up. Also pulling it into place though, so there's a little force there. Ooh, that one was way down. Nice. I'm trying to find another footprint. This footprint I'm using, the pads are okay. I mean, they work, but they could be bigger. I'm just noticing that's these diode footprints, beautiful large pads. So that would be nice. They're okay. Actually, that's something I should look into. Is the maybe it's the all of these the ground connections are all, they've got this pattern where they're only sort of like loosely connected for thermal reasons, and I don't know that that really matters. I think maybe, I don't know that I've seen that. I mean, obviously it matters for some things, but for like just these standard resistor, maybe it does not, because I feel like other boards that I built, designed by other people, the pads are all solid for both sides, the ground plane and the other side. Now either I just didn't notice and they all have that thermal protection, or else they don't, and it's not, I feel like it's important for some things but not for, you know, all resistors. So I will look into that, and because that's just a toggle option in the PCB program, whether you want the connections to be solid or not. Those all look good. These must be diodes that I'm soldering right now, because they're square pads. So that means whatever this is polarized. Yep. Now, in putting together other people's modules from kits, I've learned that a very important part of any module is the secret text that you print on the inside, where no one can see it unless you're working on it. So it says secret text goes here. That's all the secret text I've got for here. Alright. Which, actually, that reminds me of my favorite, oh, that one, I'll reflow this one bit right here. That's a little, oh, that's still pretty out there. That's adequate. That's what we go for here. Adequate. One of my favorite modules is not even a module, it's a panel, blank panel. It's the lorem ipsum blank panel with the lorem ipsum placeholder text that you use if you're for publication layout, just the slug that you put in for, you know, while you're doing design if you don't have the final text yet. And that made me laugh. And I love that module, or that blank, because every time I see it, it makes me laugh, and it made me really appreciate noise engineering before I had any of their other modules, just that. Okay. Oh, that's a good point. A large ground plane trace makes it hard to solder because it sinks the heat so well. That's a good point. I had not thought about that. I've noticed that it looks to me like the nonlinear circuits boards, I mean, I can't tell exactly, but it looks like it's all traces, no ground planes. I mean, maybe I'm wrong, but it looks like there's traces from at least a bunch of the grounds. I have a lot of nonlinear circuits. I have a lot of AI synthesis. In fact, most of them, at least one copy of most of those. Don't have the tape delay interface because I don't have a tape deck. And I don't have the most basic passive mult because I have those. But everything else I have several of. And I like building these all from one. Well, both of those are great. They're good manufacturers because the boards are, you know, they're very friendly. And they're modules that I want. And the people who design them are pretty cool, from all that I know, from either having emailed them or talked with them or just heard about them, seeing their responses in forums, whatever. That's a big part of what I like about all of this. But also, if you just use all of these one manufacturer, ooh, is that going to fall off? one maker is that a lot of times they use the same components, so you can build up a collection of components and not have to order fresh every time. So that was I did that first with AI synthesis, where I made a big spreadsheet of all the different modules and a lot of overlapping components. I just ordered many because they're really cheap if you order a bunch of them at once. Resistors are a penny each. So and you could see, which, like, 100 kilo ohm resistors, often they're used all the time in Euro racks, so get a big bag of those. I don't know that I would offer a pre-built. If I did start selling these, I do the pre-built option because not that fast or neat. I'm neat enough most of the time. I still have a collection of unbuilt modules. It's actually getting small. I only have four now that are still on my build that are not my own, that is. Okay, done. Now, capacitors. I'm actually going to do the, let's see what else I've got here. This is diodes and transistors on this one. That's all that's left on this board is 2 transistors and 2 LEDs. So I will get back to those. On this side we've got some headers and capacitors. I forget what the best order to do these. I think I'm going to put the IC header, whatchamacallit, on first. Where is that here? This is for the TL072, which is a dual op amp. Because this thing you need to sort of just lie flat, so I don't want all the capacitors that go around there would get in the way of doing that. Alright. Reflow, pushing it flat. Do this one as well. Okay. Flat. And do the rest. Now, these little capacitors around here. Got this is another one of these ones that you can have lots of. This is the 0.1 UF, aka 100 nano NF. This is a little capacitor that you just sort of sprinkle around. It's the 104 on the value there, and you sprinkle them around. I think I've got, right, did I dump out the right number here? Yep, 2 per board, 2 per module. So this is a decoupling capacitor for the power going into the positive side and then the negative side of the op amp, and that's to smooth out any IC you have. If you want one of these going from the power, between the power input and ground right next to it, just to smooth out power that's going into it. And then I also have a 47 PF. Very small. Tiny. And yes, that's to smooth something. It looks like I need more of these. I only got 10. Why did I only get 10? Well, that's it for this. Can't build any more of this module. So I get more of these. Maybe I only got 10 because I wasn't sure if this was the right value. I had a lot of conversation with people on the Winterbloom server for this part of the circuit, and somehow looking at Todd Barton's circuit and talking with people there, and then doing models in Falstead, decided that 47 PF was the right number. Is it? Who knows? Does it work? If it works, then yes, it's the right number. That's what this is all about, building confidence in these modules. I love this book. This is Nick Collins's Handmade Electronic Music, and then this is the third edition, which just came out more recently, which has more stuff in it, and it's it has specifically, it had a slew circuit, which I was trying to figure out slew circuits, and I couldn't find just one concise, clearly explained version. And right at that time, this book came out, and it has a chapter on exactly that. So I bought it. Anyway, it's a great book. It's more geared. It's definitely introductory, which is great, but it's definitely more geared toward circuit bending than module design. And so it's definitely more sort of for artists just making sound. But there's some rules in there of hacking, of circuit bending, that are great, and I think it's number 17 is the one that I quote the most, which is, if it works and no smoke is coming out of it, don't worry if you don't understand it. Of course, that's different from if I'm designing this module. I figure I do need to actually understand what's happening, and I do, mostly, but I like that idea, though. but I am entirely I've taken no classes, no official classes in any of this. It's just been building modules, reading about how everything works, taking a long time, years since I got into this to sort of understand, you know, what does an op amp do, how does it work, and so I'm not, you know, not an expert. I feel like there are a number of makers who are, you know, similar approach. There are other makers who have actually studied electrical engineering and have degrees, and their modules are generally better. But, you know, I mean, in terms of being more complicated, probably more reliable. But, you know, I appreciate that, and I buy their modules. However, not everything needs to be complicated. This particular circuit is not a complicated circuit as far as these things go. I'm reasonably confident that, well, partly because I just copied other people's modules, that's why. But those are modules that they put out to copy, and, you know, specifically Todd Barton's via AI synthesis. And it's not copying, because it's not copying the whole circuit. The circuit is a different, you know, it's a different application. It's just the building blocks. But a lot of these are just basic building blocks that, you know, you also find in the, you know, for a non-inverting amplifier, that's in the data sheet for an op amp. Is here's how you do that. So, and I appreciate all of that, all those resources. 10 UF. Now we're getting to the radial capacitors. Four of those. These are polarized, so the long lead is positive, goes through the square hole with the little plus next to it, and then the big white side is negative, and there's a big white stripe on the capacitor. So these are nice and clear which way they should go. $10 UF, $10 UF. These are, again, smoothing capacitors for the input, power input. Which is negative 12 volts and positive 12 volts. So this smooths out any fluctuation. I've got some more. I might as well do the other ones too. Those are 4.7 UF. Where were these 4.7 UFs? What did they do? Here's the schematic again. Those are smoothing out the negative input, the inverting input of the op amp through, and there's a 1K resistor, so that's, turn that off. So wait, that's filtering things, I think. It's amazing how there's just a few components that can do so many things just depending on how they're arranged. Magic. Like baking, but with electronics. I'm not much of a baker, but I just recently learned how to make pie crust. It's easy. It's flour and butter. That's it. Just a little bit of water to hold it together. Amazing. I knew it was simple, but I didn't realize it was that simple. Okay. Capacitors. Now here's one where you can definitely push up from the other side and not get burnt. Make sure the capacitor is firmly seated against the PCB. Those are pretty close together. I don't like how close together those are. In terms of bridging. I think we should get a slightly wider footprint. I'm going to test these. I'm ready to take them off. Good. No bridging. I've made a couple adjustments to footprints. I mostly have used other people's existing footprints for the PCB design. But I made one where it was, you could use the surface mount or through-hole Schottky diode for that first one. It was another one which had mostly surface mount components, and so if you wanted to just do surface mount, you could. But for that particular part, you could only get the through hole on TIDA, and I wanted everything to be available on TIDA, so without having to, do a Mouser order for just one part for Mouser. That's annoying. So, give you the option, because I have a bunch of these through hole ones. That is bridged, for sure. Yuck. Okay. And then I also have a MIDI module, which I was just put together the prototype yesterday, and I've been working on the programming, and that uses a Teensy, and the Teensy footprint that was available online had all the pins. I was only using the ones that, if you just treat it normally without doing any weird soldering on for the back pins or the end pins, I removed all the extra pins from the footprint. That was just modifying existing footprints. So I still haven't made one from scratch, but maybe I'll modify these radio capacitor footprints so that they're just like a fraction of a millimeter farther apart. These, yeah, they go through directly right now, but Oh, yeah, I wanted to test the bridging. Because that's scary to me. That's good. It's good. It's good. It's good. No bridging. What next? Oh. There's more, another... Wait, I'd miscounted the 10 UFs. There are 4. I lost some. I just totally skipped those on the bottom there. All right. No, sorry, 2 more per board, or per module. I was getting overconfident and going off bomb. Normally go down the bill of materials and, you know, do one component, cross it off, so I get lost. But here I'm like, I know all the parts. I designed this. But I'm doing 2 of them. Bridged. That one is totally bridged. That one is almost certainly bridged. Yikes. Maybe bridged. Not bridged. Yep, good. Okay. Next up, I'm going to do the power header. This footprint is designed by Winterbloom, and it's super cool because there's a slight offset with the alternating rows of holes, just slight. You can still get this through, but it holds it in place, so you don't have to sort of, balance it the way that you do sometimes. Bridged, but those are all the grounds, so it doesn't matter. Yikes. Unbridge them just so it doesn't look terrible. Whatever, they're all bridged. That's a lot of solder on there. My solder sucker, where'd it go? Doesn't matter. Check it. Great. Getting to the point where I feel like it should be done now, but there's still more parts. Now I'm going to do the transistors that are for the LED, and then that will be that other than the LEDs, other than hardware. Oh, I didn't grab this one from my drawer, so I have to go off and find that. It's transistor. It's a 2N3904. I don't have a lot of transistors. I still don't have I'm not 100% on how. I know transistors are very simple. I do know how they work, basically. But it's not just a simple open and close switch, so there's a little more math to it that I'm not quite. I don't quite have a handle on. My dad said he used to whistle while stamp collecting, which is a bad idea if you're stamp collecting, because the things go everywhere. Those little hinges. I never collected stamps. But I know there are little hinges. A philatelist. It's a good term. I think that's right? Philatelist for stamp collector. Alright. lead was sticking over a lot. Threatening to bridge. Looks good. Doesn't look good. It looks like it will work. All right. It looks fine. Next, I will put the boards together. So for that, we've got this board has 2 of these 6-pin headers. Two, and 1 4-pin header. Each. Okay. Now this board, it goes on the back side. This is where the jacks and pots are, or pot is. Now this is the top board that attaches the panel. I like to have the socket on that side. It doesn't necessarily matter, but socket on that side, and then the headers on the other side. So this is the other one. Now the part where you plug it in, the tall components, faces out. Oh, it doesn't matter. I have to still have to put the op amp in. I forgot, but this is not permanent. Wait, I forgot. And then this one here. There. Now the rubber band. A very important tool. I'm going to put them both together. Do it all at once. I'm Great. Oops. I got a rubber band. The first rubber band that I got was the big honking button kit from Winterbloom. I reused that rubber band an amazing number of times before it broke. Every other rubber band, they use quality rubber bands there, I don't know. Okay. Bridged. Yikes. Sometimes you just have to use a solder sucker. I hate this thing. It's terrifying. Solder flying everywhere. But it also works. One. Hello, welcome. You've arrived just at the, nearing the end, almost built. This is the point where I'm like, this should be done by now, but it's not. But, on the final pieces of hardware, the thrilling conclusion. Will these new modules work better? Maybe when I recommend the order to solder things, I'll say enter board headers before that thingy. Power, but so that was a little awkward right there. Of course, if no, that wouldn't be as awkward on the other side, I don't think. A little far from the fan here. Bridge! That's the first attempt is just flip the solder out of the way. Yikes, fun. Yes, definitely need a beta test crew. Of course, I didn't make that many of these boards this first round because I wanted to make sure they worked. But yeah, I was just testing out to see how much like the setup is the expensive part. Adding more boards is pretty inexpensive. I mean, going from 5 to 10 boards is not much. Oh, wait, I did that side already. Wonderful. What a surprise. I lost count of how many sides I've done. So now it's going to break. I'm going to carefully unwrap it, and then it's going to break anyway, so might as well just cut to the chase. Okay. That side is done for now. Nope, this is the side that has the IC. I forgot to put that op amp in. There we go. TL072. Op amp only has a little dot to indicate which way, which is pin 1. So killed it. Oh, the leg's bent out of place. I have so many op amps. Normally I'd try to fix that, but I don't have time for that on the stream. Gotta get to the end, finish this up. And also, I just organized all of my components, which were all over the place. For the last few years, I really haven't kept them as organized. So I organized all of them, and TL072s and TL074s are. It's like every time I place an order, I'm thinking, oh, I'll just get 10 of those, because you never know. And as a result, I have so many of these, which is great, because they're often used for things. Alright, great. That's done. I'm building 2 of these, by the way. If you're just tuning in. So I want a bunch of them built. I think I might as well do 2 at once. Sometimes that goes faster, sometimes it doesn't. But also, it's probably the last time I'm going to be soldering for a little while, so get some things built. Alright, all I have left are jacks, potentiometers, and LEDs. So here we've got I only need 2. These are the Thonkacon TRS. They're the same footprint as the standard mono Euro rack jacks, but they're stereo TRS. They're a little bit wider, but the footprint, the whole layout is the same, which is nice because so many, if you look for the TRS jacks, so many of them are the sideways type, and a lot of them are switching. You really don't need all that many. I don't need to switch this. So this is perfect. There's that. You know what, I'm going to put the potentiometer on first because I think that's going to, it's a little more difficult, so it's going to make the jacks fall out. So, all right, these are dual gang B10K, which are, even though it's an audio circuit, these are, and so for audio circuits you would use the exponential, what is it, the A audio jacks for the exponential curve. Is it exponential? For audio, but this is not audio that's going through here. This is just feedback for the current for the op amp, so you want the linear potentiometer. And as I was saying, the redesign for this, I wanted when I originally designed this module, I wanted a 20K potentiometer here, and after placing the board order, learned that don't exist. The dual that one's bent. Dual linear 20K potentiometers just don't exist, or at least I can't find them. So, so this board design has a secondary to standard resistor in series with this, so that it just offsets the whole thing, because I don't really ever need to be at the very bottom end of it. The bottom end of the range was, you know, a little wasted, because the bottom end was unity gain, and the whole point of this is to boost it so you can actually start much higher up than unity gain, and it'd be fine. This is not going in for some reason. Is that hole not cut well? Try a different jack, or potentiometer. I think this hole is not big enough. Yeah. Oh, it's raining outside. All right. This is not going through. There we go. All right, those are in. Somehow the jack did not fall out. I'm not going to take that. I don't like these knurled nuts, especially the ones that come with the potentiometer, the cheap jacks from Tata. Like if it's a quality one, then you can use a knurled nut driver and it works well. But these, I mean, the knurled nut driver works, but very often they don't thread well. I like the hex nuts. So I have a whole tin of hex nuts. Now the Bafako nuts, the colorful, the Bia nuts, are they called? Because they look like banana jacks, but they're not. Or I don't know how they're pronounced or spelled, but anyway, they're those are higher quality. That's a different story. They're also expensive. Okay, those are on. And LEDs. So I pulled all the things out here. I forgot to grab LEDs as well. I'll be right back, going to my drawer of things. There we go. I'm going to go with red. Maybe I should go with green. How would that look? Probably look nice. I'm going to go with red. Actually, white would look nice too, but I don't think I have any that are dim enough. I mean, I could, of course, change the resistor values, but red's fine. Classic. There. Okay, I'm actually going to use one of the old panels for soldering purposes, so if they get scratched up I don't care as much. Actually, I could just hold something else with the gator clips. Here we go. These are the beautiful new blue, larger font, circle instead of random values panel. How's that? Great. Yes. LEDs and pot into a face, yes. Now that was a little tight for those. The other, just putting together a NLC module, and they go a little extreme in the other direction. Some of those holes are huge. Solder's just floating around for days in there. And actually, one thing that happened the risk with that is that as you're feeding the solder in, it goes through the hole, and then you end up with like a bunch of unmelted solder wire inside the module. It doesn't happen often, but I'm always afraid it's going to, and it has happened to me. But I mean, I always catch it, so it's not a problem. But ooh, that's bridged. Too much solder. Of course, those are connected, aren't they, anyway? Or are they? No, because that's the TRS one. So those do need to be not bridged. Did I get them all? I think I got them all. Lovely. Lug jacks, yes. See? Broke these. Cheap rubber bands. Staples rubber bands. I mean, the wise thing to do is test it before you put these jacks on, but there aren't that many jacks, and I'm feeling confident. And yet also clumsy. Yikes. This is where you notice the quality difference. These are the cheap jacks. I actually came across, when I was organizing, I came across a bag of genuine Thonkacons. Not the, you know, inferior ones you get in bulk, but anyway, just try to find those. I figured if any module was worth it, this one is, but then I couldn't find it. I also need to get a new one of these. This tool is the greatest tool, but I've had it for a long time. It's getting completely worn down, so at some point it's going to stop working altogether. I got it from lovemyswitches.com, and they used to sell them only in sets, but now they sell them as individually as well, which is nice because I only use 2, which are that size and then the bigger jack size here, which is, here are the pots, I mean. The pot size and then the 3.5. Boom. This one is number 3, and it's done. And then this one is number 4. Okay, this one, I want another 1U that's in the new version 1.5 in 1U. So I made 2 of them. Oh! The rubber band broke before I even put it on. I'll write a letter to Staples. Alright, let's see. Yikes! Gotta be a little more gentle with this. 1U is just too much for the rubber band to handle. That works. Speaking of faces drawn on modules, the EuroPie always admired the green panel on your EuroPie, which you have said it was not intentional initially, but I've always wanted more green modules, so I know I think I posted a picture of this before, but this is what I was working on earlier today, testing out. This is the Atom module. It works. It's not 100% yet. I still have to program it. This is the Teensy 4.0 on the back. This is number 1. But this is a analog to MIDI. So basically it's got 6 trigger inputs and 9 CV inputs. And a button, which you can do whatever you want with. And an LED, green, and then MIDI out. And it seems to work so far. There's a lot of jitter on the CV inputs because I'm using the Teensy's onboard analog to digital converter, and I mean, I don't know what else is, if there's anything I should have been doing with the circuit to smooth things, if there's electrical issues going on in there, but I pretty much used a lot of I don't know what the deal is, but it's also like not more jitter than I have had with other projects, other Teensy projects in the past. So fortunately, I only need 7 bits of resolution for the MIDI. So if I reduce it to 8 bits from the standard 10 or 12, it's actually pretty. Yeah, exactly. And then it's actually fairly stable. And then if I oversample, so I read 3 or 4 times in a row and then take the average of it for every time it reads, then it actually becomes very stable. And also reading several times in a row. Long ago, I heard that was actually a good thing to do, because when it does the first read, it's actually warming up in a way. So if you do a bunch of rapid fire reads on any one pin, or if you just even do 2, then the second one's going to be a little more stable. And this is fast enough that I can do as many as I want. It's not going to really impact what's happening here. So far I've tested the triggers, work fine. CV in works pretty well. The MIDI out appears to work with the one test thing I did. The button, it works. The LED lights up. One problem I have is that I made this last CV input go into pin 13, which is the LED, is wired normally to the LED that's on the onboard on the Teensy. In the past I've done that, and I thought that if you wire it to not be the LED pin, then it's you can use it for whatever you want. But for some reason it's not working. It's automatically, it's still like CV into here doesn't show up, doesn't go out through the serial. It is affecting the LED. So I have to do a little forum searching, seeing if there is some way to overcome that. It's also frustrating because I could have easily just shifted all the inputs up and left 13 empty, because there are a few up here that are unused. So totally unnecessary, but anyway, that's what I have for this version. And then there are jumpers where you can make each. Oh, wait a minute. Hold the phone. Maybe. Oh, okay, I'm going to try something else out. Why maybe this one's not working as well. The jumpers where you can switch between unipolar or bipolar for any of the inputs. Still have some more troubleshooting to do to see if I can get 13 to work. But if I do get it to work, then I just have to program it to do stuff, and that's pretty straightforward. I mean, even for me, I'm not a programmer, but making MIDI, making modules that convert analog signals to MIDI is the one thing I've been doing for a lot longer than I've been doing Eurorack, because I'd make MIDI controllers for various projects, so that I can do using Teensy specifically. But yeah, I've never had this issue with pin 13 before. But I've never used a Teensy 4.0 before, so I don't know if there's something different with that than the 3s. That's it. And then ta-da! All right. I'm going to plug this in. I'm going to clean this off. Give me just a second. gonna do a quick wipe down. Get all the solder. I've been soldering for days on this without wiping it or moving it. I want to get this out of the way so I don't have lead all over the bottom of my my pod. Test case. Uh-oh. I didn't set this up yet for audio, so I actually don't have. Yeah, I haven't configured this to. Arg. Let me turn on some audio. Reaching speakers. Okay. Oh, throw that around. Plug. See if any smoke comes out. No smoke. Good sign. Sorry about this. Gotta set up the audio first. Okay. Right. Line out. Left. Line out. Let me get OBS over here. Make sure I got the input. Oh, I don't even have to do that. Adding audio input capture. Boom. Okay. Have the audio coming in now. Turn it on. Okay, I can't hear it. I don't have any monitoring on this. Maybe if I turn that up. Nope. That's the problem with this setup. I don't have the... Can you hear this, everyone? Can you hear this? Okay, great. I can't hear it. However, I I won't hear what I'm hearing, what you're hearing on the stream. I'll just go directly out of this. Great. Now I need a TRS cable. Okay. I hear it. In stereo even, I think. Where's pan? Oops. Pan. No, yes. Okay, that's hard right, yes? Great. Now this is all the way left, so it's boosting it more than the old one. Oh, and these work. Oh yeah, and even that shows up, it's on the right side. Now comparing it with this, which is at nice full Euro level. Fun. It works. Hold on, I'll leave that. Oh, no, I won't leave it there. I want to try the other one, just make sure the other one is working as well. That wasn't going as loud as I kind of... the gain is not as dramatic as I expected it to be, but you know, with a change, but I think it works. In show of hands, people on the stream, who would be interested in the 1U versus the 3U? Like, is the 1U of interest if I made more of these panels? Just curious. I'm specifically going to use this for my dollhouse rig, which has a 1U panel. Works! Yeah, this is not... The gain's not quite as dramatic through these headphones anyway as I expected it to be, but it's better than it was without the additional resistor. Of course, yeah, the whole point is there's now a resistor in series, so I could add a bigger resistor, I could add a 10K resistor, and then it would go even louder. That's pretty subtle. But whatever, it works. That's the key thing. I really wanted it to drive. This might hurt. Let's see. No? You can hear some harmonics in there. All right. I guess that's it. Thank you for tuning in for this this soldering stream. And I will see you all around.